Welcome back. Today we'll talk about how to build Linux kernel. Last time we talked about how to do the how to play with Linux kernel preemption models. So obviously you might be wondering, hey, how to make the kernel? So how to make the kernel? We'll start with very simple steps, 4 or 5 steps that will have you a new kernel installed in your machine. So, what is the first step? The first step is to get the kernel source. And how do you get the kernel source? So, you get the kernel source by basically create a directory in your virtual machine, and GCP gives you a virtual machine, so you don't have to even pay. Google Cloud gives you a virtual machine for 3 months, and they give you some credit. So let's see that. So we'll do the like for example, what you can do is you can do clone. See, so you have to use a command like that, git clone git, and usually I download it from this particular location, which is Linux kernel git stable, Linux is stable, because many people also download the kernel from Linux Store World's repo, but I like to use this one, git clone git kernel.org and things like that. So if you do that, you would see that this is what will happen. You say cloning into Linux stable. Now, when you say cloning into Linux stable, you will get a directory by the name Linux stable. Now, as you know, the Linux kernel is now almost reaching um, 7.0, even though right now it's only like 6.1 or 6.2. But bottom line is, it's a huge source base now, supporting many architectures, many different hardware CPU platforms. So it can take a long time. So I will just save you for the sake of the video. I would just go to something that I already did. So after you do this step, git clone git kernel.org, remember pub-scm Linux kernel get stable Linux stable. You will get a directory, and as I just showed it to you, you're cloning into. What happens if you fire this command? You will end up, if you wait at this step, you would end up with a directory known as Linux stable. Now, what you do after that is that before you can start building, when you have a fresh source base like that, you would see that it doesn't have a .config file. You need that .config file. So you see ls-lt.config. This file, without this file, you won't be able to build. So many people, what they do is they do something known as make menu config. Now this is, you see, I'm doing this on CentOS. So make menu config, but then that would take you a long time to answer like hundreds of questions. If you see make menu config, see it's saying this C compiler is not supported, it's too old. So I mean, that problem we can solve, that's not a big problem. Now what we need to understand is that um, if you want to solve this problem, GCC hell, I may gave this file, so you just have to do this, I think. But that you may not have to do, because you may have a latest Ubuntu or something like that. So that may not be the requirement version. So you see here, what did I do? I said here make menu config. Now let's go back to again Linux stable and say make menu config. Now the last command that I fired, that is enable, that's a CentOS hell, and as I correctly name the file CentOS hell, so you may not have to do that. All you have, if you have a latest Ubuntu 20 or Ubuntu 18, you have the required kernel version. So in this case, I think I had a little bit older CentOS and it didn't have the right compiler. See, that's why I was saying is GCC 4.485. But in any case, so you need, this is all assuming that you are on Ubuntu 18 plus or CentOS 8, 9 or something like that, not too old. So if you see make menu config now, you see what happens. See this. So you get all this huge, even though it's a little bit better organized, you may have to answer questions here on what kind of like general setup. Let's go to general setup. Now here you may have to answer question. Now it could probably conceivably take hours or half a day or even the full day if you really want to understand, because they have a hell also. So for example, you come to this preemption model here, voluntary kernel preemption desktop. We go to help here. What does it say? It says there is no help available for this general setup preemption model. So exit this. Now preemption behavior defined on boot. Yeah, you can do that. You can. So basically, what happens is, suppose if you say preemption models, select. Now you see you get three choices here. You get preemption model, no forced preemption. We talked about this. We said here, kernel code is not preemptible. Basically, kernel runs to completion. Voluntary kernel preemption means kernel you can, if you want, in the kernel, inside your kernel code, kernel thread, you could call something like might reschedule or something like that, and it will basically, it's another way of saying process may suspend or the thread may suspend, but thread here is kernel thread. So here number one, no kernel thread runs to completion. This one, kernel thread may preempt, may get out of your way, and number three is kernel thread will be preempted. Even if it is a kernel thread will be preempted. As you know, the Unix is a preemptible OS, so the user thread is always preemptible. But even in this case, you are saying even the kernel threads can be preempted. So let's get out of here. I choose voluntary kernel preemption. So that means if I want, I can get out of the way. So that's all these things will happen, and then you will go through a big huge bunch of options with drivers, networking. See here, you got networking support, now device drivers, now all that. So tons of options will take probably half a day if you go to. So again, let's see just before we get out of this. So if you see here, for example, if you go to device drivers or you go to networking support, now you see, do you have a CAN bus in your system? Probably not, right? So you don't have to have it enabled. See, you see, if you say select here, and then it gives you options, a star or say exit. Now you say okay, so you have to press space bar to see here, if I press space bar, it comes module. That means we will build the module for it. Now or if you say star, that means it will be built in the kernel. And if you again press space bar, the all the options go away. So in that case, it means neither the module will build nor will build the kernel. So basically, you can save a lot of build time and unnecessary modules or kernel bloat when you don't need any of this. Now Bluetooth. Do you need Bluetooth on a server? Maybe not. So that is why I had disabled this. So just want to show you that these things are possible. Like for example, do you need wireless? So you can go here, and basically it's a good way to play and learn about kernel, Linux kernel. So for example, if you want to know here CAN bus. Now let's see what kind of help they have for CAN bus. See, so here you see so much useful information is given. What is CAN? Is a slow serial communication protocol. Development of the CAN bus started in 1989. See, think about it. That's a huge information. So you could actually take the opportunity to do Linux kernel build as an opportunity to become more familiar with systems, software and device drivers and different kind of buses and hardware. And I mean, this could be itself considered a huge learning opportunity, just building the Linux kernel. So I would definitely recommend anybody who is serious about playing with kernel to try to build their own kernel, and don't be in hurry. People just want, I want the new kernel. No, just sit on it for whole day, like go through all the choices. See, so after this, let's say you want to let's go to the device driver. Do you need PC card? No, right? So you say just I just disable this is just by pressing space bar. Now rapid IO support, GNSS receiver support. What is that? So let's do the help here. Say it gives you some information, I guess, not very useful in this case. But memory technology, do you need that module for that? Probably not, right? Or if you go here, see, it's completely gone now. Now plug and play, okay, NVMe, SCSI, serial ATA, Fusion MPI device support. Why do I need that, right? I don't even know what that means. So if you don't know what that means, you can always press the arrow to go to the help and say help. Fusion message passing technology drivers. So here you have I2C, I2C, SPI, SPMI, HSI, PPS, PTP, tons of. I'm telling you, it will take you whole day actually if you go through all these options patiently, no hurry. File systems. Now, do I need? Let's see. Do I need Razor FS? Do I need here? Let's say JBD2. Do I need here? Let's say BTRFS support. Do I need NILFS2 or what are all these things, right? So if you say BTRFS support and you go to here help and see, let's see what it says. It says, oh wow, that's a huge. It's like a small tutorial, right? General purpose copy on write file system with extent. So the Linux kernel building opportunity is actually also a learning opportunity, I would say, in many ways. Not just building the kernel. You start understanding like what are the different buses, what are the different. Now kernel hacking, you want to have network debugging, you can want to have scheduler debugging, things like that. So uh, bottom line is play with Linux kernel, make menu config is your friend, and you might see that during make menu config you might say, oh, you have ncurses package missing. So in that case you may have to do a, if you do a curses, you may have to do a app yum install. So you say control R and you say, if you say it like this, see this. So you may have to do this if you are on CentOS. If you are on Ubuntu, you don't have to do this. So as you or you may have to do, but you may have to. The package name might be slightly different, but it would have curses in that anyway. It might say live and curses dev or something like that. So you see sud yum install and curses dev bison flag. All this you need, and I'm assuming that if you are on Ubuntu or if you are on CentOS, you have already done install build essentials that gives you GCC, all the required packages. If you are on CentOS, you have done group install development packages, things like that. So this in this case, since I have already done this yum install and all these things, there is no need to do this. But you may see that when you do a make menu config, it asks, says sorry, I can't do it because you don't have curses installed. So you have been warned, so you may have to install all that. And after that, the next step comes, because we are assuming these things are done. So that is why Linux kernel building and installing could take half a day or full day, depending upon how deep you want to go into it, or you just want to fire a bunch of commands. So the next step is making sure that I already showed you that once you save your config, you will get a .config file. But if you don't want to do that, then what happens is that you can fire a command something like um, from your running kernel. This is very useful. You see, if from your running kernel, this might be a good idea to start from, because if you don't want to, suppose I don't have too much time right now, and I just want to build it in an hour or something like that. So then I can take a .config from running config like this, right? And then suppose I say that I only want to change the preemption model, just one. I just want to tweak, as they say, one parameter. Now, he say input file is output file. .config, I see. Cat this greater than .config. Here, what is a cat live and .config? Okay. Here, if you don't do this, let's say that greater than. Okay, .config has come here. See, cat. Oh, when I did a cat live modules in a minus r, nothing happened. I'm surprised what's going on. Maybe I've installed new kernel here, but usually you should have it. You should get this cat. See here. Oh, because I installed and maybe that one doesn't have .config. But usually, if you have, if you download, if you are in your completely new virtual machine, you should be able to use this command cat lib modules unum -r build.config to get a running config. I think I used that once to see all these running config one. I got it by using this cat lib modules unum -r build.config greater than .config. So try it on your system, it should work. And that way what happens is you can leave most of the things as it is when you do make menu config, and just change the, let's say, the preemption model or something like that, right? So so that's there. There we go. Kernel compression mode, preemption model. Okay, all right. No, we'll not waste any more time on this. Let's go to the next step. The next step is, after you're done that, the next step is to do make -j4. So you see, make -j4 without any options at this point. Just say make -j4. Now this might take whole day, depending upon it, like how many options you have enabled. Like you may be building different kind of drivers like NVIDIA to Intel to so it could take considerably. But if you have very few options enabled in your menu config, then you might see it takes only like a couple of hours. It used to be that when Linux was 1.0 or 2.0 or 3, it used to take 10 minutes basically. But now you see Linux has bloated a lot, and it has so many more features. As you can already imagine, it's being used by all over, by every company in the world. So so Linux is has grown a lot basically. So as you can see now, it's building. It will take a whole day, and if you build like that, then you have to, after building, you have to do make module. After this is done successfully, imagine that you don't get into issues. Now I can see some issues at this point already. So what will happen, I can see for you, is if you're doing from scratch, that at some point we'll say some PEM file is some certificate and some, so you may have to remove, you may have to search for PEM in the file and then remove all this those double quotes, the PEM files inside the double quotes. And I think that is this trusted. If you see trusted, this certificate. So if you see certi, so where is the PEM? Okay, let's search for this PEM. Okay, no. So I'm just telling you that you may have to remove this PEM related stuff in your .config if you want to speed things up. And after that, when it is done, you'll have things ready. And if the make -j4, make sure the make -j4 succeeds. And after that, all you have to do is make modules installed. Number one step. And after you do this make modules install, I don't want to fire it right now because I don't want to install. This is already done in my case. But in your case, after this make modules install, you may have to do make install, and then you just have to do a reboot. I think it takes care of, make install takes care of making sure that your grub configuration file gets updated and things like that. So Linux kernel build can be very involved. It can take whole day, half a day, or where depending upon you're on CentOS or you're on Ubuntu, you might see that you may have to play with the grub configuration files. So after, I even have issued where I built and I followed all these steps that I told you, but I see after the virtual machine came back, I mean it rebooted, the old kernel is still running. Then I had to play with some grub configuration files on the CentOS side. I think on Ubuntu that was not a problem. It automatically made sure that the new kernel is booted. So I hope this was useful, and with that I would leave you alone, and I hope you get plenty of time to do your kernel hacking, and it is something that will can conceivably take the whole life or whole day or whole months, if you depending upon how much you are interested. I mean, you could even end up contributing to the Linux kernel. You may end up contributing to the open source code and, as they say, upstream. So, best of luck. I hope you achieve your Linux kernel dreams. And with that, bye bye.